Hello guys, in this video we'll build image generator, a cross-platform application using Rust. The purpose of this video is to put in practice all of the concepts, be it RSX, components, hooks, async programming, or any other different concepts that we have learned so far in the cross-platform development series using Rust on my YouTube channel. So we create a basic application before we move towards more gigantic projects. So we'll put in practice most of those concepts and we'll be using AI for image generation, where we'll also experience async programming. And one of the concepts which is kind of basic but left still in the series is using Tailwind CSS, which we'll use in this video. So make sure you hang tight, watch till the end, and as always, if you have any questions, feel free to drop in the comments, or you guys can join my Discord, link in the description. And let me tell you guys, if you are not yet on my Discord, you are missing out on a lot of discussions and projects that we are planning there. So make sure you join. So let's begin. First of all, move to the project explorer and make sure you are in a nice and clean project. Open the terminal. Now, if this is the first video you are watching for cross-platform development on my YouTube channel, then make sure you watch the previous videos. It should be popping somewhere on right top, so you understand all the basics as well as the CLI before moving on to this video. So we'll just do dx new, and here we'll select the web template, but today the application that we are developing will basically demo it on both website and desktop. So we'll just press web and project name as image G, and yes, we need Tailwind CSS today, so make sure you select Tailwind. And router we don't need because we are just creating a single page application, so router to false. And we have our project. First of all, move to the cargo toml file, where we'll be adding a few dependencies that we need, and just remove Dioxus logger because we'll just not use logger today. And here we'll add Surday because we'll be adding a few structs, and we need serialization and deserialization, so features as derive. And then we need Surday JSON to pass on JSON to our endpoint that we'll be using for image generation. And finally, we need request for HTTP client. Make sure you add all of these dependencies. So once all the dependencies are added, move to src man rs, and here we'll just remove all of this default code since we'll be building our own application. Now move to the project explorer, and in src add the components directory, where we'll add a generator rs. Here we'll add all of our components that we need for our image generator application today. Now there are two ways: either we can add separate rs files for each component, or separate functions here for each component. Today we'll stick with one file but separate functions for each component, which we'll see in a minute. So let's get on with it. So before we add any component here in the main, we'll just do mod components and pub mod generator, just so we can get on with it. Now first of all, we'll add some side components that we need, for example loading and displaying. Then we'll add the main component. So let's say we have a loading indicator. When we call the image generator API, we need to show some thing to the user, so we'll just show this loading. And rsx div, and here class we'll use from the Tailwind CSS, so flex justify center and 4. And then we'll just add another div with class as loader is, linear rounded full border 8 and border D8, border gray 200, H32, W32, and that's pretty much all that we need for this. And on top here we'll just add star. Okay, so we have our loading indicator done. Next is our image display, but before that we need a few types or struct. So we'll just add struct URL image and URL string. Now this depends on how the response of your API looks like. So I'll be using OpenAI for image generation, and the response is pretty simple. Just sends you an array of URLs where the image is. So we'll just do derive, serialize, deserialize, debug, and partial EQ, since we'll be using it as props, and clone. Now next one that we need is image response. This is same to how we define types in JS. So serialize, deserialize, debug, partial EQ, props, and clone. And here we'll just add created, let's say, and data. So this is how OpenAI sends us a vector of URLs. So we have our structs ready. Now we will add our display component. So we'll just do fn image display images and vector URL image, and this also returns you an element, again on top component and RSX. So we'll just do for image in image dot iter, and let's add a bit of CSS, but I'll just add it, and if you guys need it, you can just request anytime. I'll share the assets. Okay, so this is how it looks like. You can just pause the screen and write, because no point wasting time on CSS, since it's just Tailwind CSS. We are just referring to it, the main point where I'll stop and show you guys how we load the CSS actually. But here we just referring to a bunch of classes, so no point wasting. You can just pause the screen here and add this, pretty simple. And then we pass the srcs image URL. So that's pretty much how it is. And if you want to give any alt or alternate text, you can. For me, I just leave it empty. So this is just a basic image display component. And now let's add async function that sends the request. So async fn request, and what we pass is basically a prompt, for which we'll add a text box in a minute. So result of this is image response or an error. And we just create a client, and then let's add the body. So we'll just do JSON. This is from Surday JSON, so we need to pass prompt. Again, this is the model that I'm using is for OpenAI. For any other model that you are using, you need to accordingly provide. And we want to generate a single image, so n is 1, and size as let's say, I'll just say 300 by 300, or maybe let's go a little large, so 500 x 500. And we have our body. Now let's send the request. So response client dot post, and right here we'll paste our OpenAI URL. So for me, I'll just refer to one of my internal proxies, but you can refer to anything that you want. OpenAI dot semicolon /v1 images, and generations. This is the API that we are using. And then we have body, so body dot to string, and then we have header where we'll send the content type as application JSON, and authorization as some bearer token, which you guys should have. So your token, and we'll send the request, await for the response, unwrap the response, and text, await and unwrap. We get our string, and here we'll just deserialize it. So we'll just do let response is equals to image response surday JSON from str and response, and okay response. Or we can just use, okay, so we have our deserialized result here, and image display loading, and now just we need is a main component, which is image generator. So we can just add the main component now, pub fn. This one needs to be public since we want to, you know, render it, launch it from main. So we can name it generator, and element component, so let mutable loading use signal, again the state concept that we learned in previous videos, and some prompt that we have. So we can just do string new, and for this to be empty string initially, and then we have image use signal image response, and initially we assign it to created at 0, and data is vector new. Pretty straightforward, some basic states here, and then we add generate images future. So use resource, again as I mentioned in the previous async programming video, use resource when we want to fetch something, but and then return the result from future. But if we don't want to, then we can use future. So here we want to return the result, so let's use resource. And so here we'll just add let prompt dot peak and clone. So we'll just check if prompt dot is empty is false, then we want to set loading as true, and we want to match send the request, pass the prompt, and await for the result. If it's okay result, then we set image state to the result that we have. And if that's not the case, then we get some error, and we can log this error, we can print this error. Since we are not using log for now, we should have used, but I'll just add print here, error, and print whatever we get. So pretty straightforward here, nothing fancy. And once we are done with this, we'll just set the loading to false. Finally, let's add an RSX for the component. So let me quickly add and show you guys. So pretty basic stuff here. Again, you guys can just pause the screen and code this. So input box to take the user input, which is basically our prompt. And that's the only parameter that we are taking right now from the user. If you want, let's say, number of images, which we hard coded to 1, or even the size, you can, but I'll just stick with this. And as you can see, we take the input and placeholder, we can set this to max 1000 digits, or we can say write your prompt here. So straightforward. And then we have the button, and basically on every time the button is clicked, we just restart our future, which is this, or rerun use resource. So this will generate the image, and then we just show the loading indicator if it's loading set to true, and we just finally display the image, which is again our display component. Nice and simple, easy. I'll drop this all CSS in the assets in my GitHub. If you guys need it, you can check from there as well. Pretty straightforward. So let's move back to main, and here we'll add an app element. So right here we'll just do is an RSX and components and generator, and then our component, which is generator. So here we are able to use our component and refer to app to launch. Pretty straightforward, simple. So let's launch our app for the first time and check our application before we start to the final thing, which is Tailwind CSS. So just open your terminal and move to our project, and here we'll just do dxserve. So it's up and running, and let's go to embedded browser and we do localhost 8080. As you can see, our UI is there, but what's missing is bit of CSS. So let's just refer to that. We just added already, but now we just have to refer, which I just wanted to show you guys how to do it properly. So first of all, move to the project explorer, and in Tailwind config.js, make sure that wherever your components are, it's properly referring to that. So for me, it's src components, as you can see, src, and then some other ** any directory, and then inside any rs file or html or css. So as you can see, our generator component will be referred. So first of all, you guys have to check that in default template your file does fall. Otherwise, you can just add as many formats as you want here for basically looking up to those files. And once we have that, just move to your terminal, and you can close it for now, and just move to your project. So we'll just do cd to image g, and then make sure you also have input.css with all these things. In the default template, you get it for free when you select Tailwind CSS in Dioxus, but just make sure you have it in the root of your project. Now once you have it, so just run this command npx tailwind I input css, which is again in the root of project. But again, if your input css is in a different directory, then just refer to that and just refer to public Tailwind CSS watch. Just run this command for the Tailwind compiler to look into things and generate the CSS. So just press enter. So if you get the same output as I do, then we are all good. Our CSS is up and running. And don't just close this terminal, because if you make any changes while you are checking your code, so those will be also counted kind of. So move to image rs. The final thing that we have to do is just refer to this css. So we'll just do style, and here we'll just do include str, and just do public / Tailwind .css. So as simple as this. And why we do this? Because our CSS, generated CSS, is inside public, inside this Tailwind CSS. As you can see, all of this based on what we put inside our component right here, everything is generated. So we just refer to this in the topmost component, in the application component. That's the only place you have to refer to. And then just open your other terminal window and just to dx, just move to image G and just do dx sub. And let's move to our embedded browser. Okay, as you can see, we have a pretty better version of our application up and running here. So let's provide any prompt, and let's say the prompt that I am providing here is a dog image, and just press generate image. And as you can see, we see our loading bar, and as our image is generated, it goes in and renders our image, which is indeed a dog. So our basic app works, and we have tested it for web. Now let's test it for desktop as well. So just close this window and move to cargo terminal. Here we would have added features desktop as well, and then we can run both, but for now let's change web to desktop. And back here we'll just do cd image G and dxf. So as you can see, the code, everything remains the same. I haven't touched anything, just do a dxf. So here you go, the first look of our desktop application for image generation. And again, here we'll give a, let's say, a different prompt, skyscraper image. So press generate image. So the UI is same, but why you saw a dark mode in embedded browser is because I'm using a dark mode in IDE. But if you run this on a web, you will see a different same UI basically. Okay, here you go, we have our skyscraper ready. So as you can see, it runs fine. We are able to generate our images, and we have a first project which is cross-platform application. So I hope you guys learned something new. If you do, like the video, share with your friends. I'll catch you guys in the next video. Bye bye.